Euglena is an open source computer vision plugin for Grasshopper. Behind the scene, it uses Mediapipe, which is a machine learning framework developed by Google. Mediapipe requires Python 3, which was not completely available in Rhino 7. But fortunately, Rhino 8 introduces a new script editor that lets us use Python 3 in both Rhino and Grasshopper. So technically, this plugin is only compatible with Rhino 8. Let's see how to install it. First of all, make sure you have installed the latest service release of Rhino 8. Currently, Rhino 8 is yet a work in progress, so thankfully you can install it with the same license that you already have for Rhino 7. I've put the download link in the description. If you have already installed Rhino 8, you can check for updates by going to Tools, Options, Updates and Statistics. Before you move on to the next step, it is best to run Grasshopper and make sure that the script component is working. Now download the installation files from Food for Rhino. You can also find this link in the description. Now that the file is downloaded, you gotta make sure it is not blocked. In order to do this, right-click on the zip file, go to Properties, and if there is an Unblock checkbox here, enable it. Once done, unzip the file. Then simply open the installer.gh in Rhino 8. There are two script components here. The first one installs Mediapipe. If you already have Python on your system, installing Mediapipe on it wouldn't help, cause Rhino uses its own Python installation. Anyway, don't worry, this component handles the whole process for you. Just wait a few seconds till it's done. You will get a succeed message when it's finished. If the installation fails, you will be provided with some instructions on how you can try installing it manually. After installing Mediapipe, you need to run the second script component. This will automatically copy all the plugin files to the user objects and components folder. You will get another succeed message and the Euglena tab will appear on your Grasshopper interface. Usually there is no need to restart Rhino. Here we have two groups of components, Utilities and Vision. Every component on the Vision tab has an input called mat, which is a matrix. It is actually a NumPy array that represents an image. To create a mat, we have different components on the Utilities tab. To show you guys how it works, I'm going to use the load image component to create a mat from a file. I will need a file parameter, and I'm going to open this image. It supports BMP, JPG, PNG, and many other image formats. Let's run a computer vision task on this image. Here I am using the face detector. It will find two faces on this image, and it gives us a bounding box for each of them. To see this image in the viewport, we can also use the import image, which is a native Grasshopper component. When it comes to working with images, Grasshopper is not the best tool. To push the limitations, we have released a plugin called Javid. You can download it from Food for Rhino, or you can simply install it from Package Manager. Then you will have access to a whole bunch of tools that makes it easier to work with images. Javid has its own bitmap parameter that makes it possible to store bitmap data directly in the Grasshopper file. You can simply set one or many image files like this. Now we have our image internalized in the bitmap parameter, so we don't need to save any image separately. You can also download an image from the web using the download bitmap parameter like this. There is also a preview bitmap component that lets us view the bitmap on the canvas. We can set the zoom level or even lock the aspect ratio. What we have now is a bitmap which Javid works with, but Euglena works with mat. So first, we are gonna have to convert it. We can do this using the bitmap to mat component from Euglena. There is also a mat to bitmap component. Let's see how all this works together. Here is the camera stream and preview bitmap component from Javid. As you can see, we can choose the camera source and resolution, and we can even change the frame rate. Let's use bitmap to mat. The output is now a matte, so we can run any computer vision tasks on it. Let's try face detector one more time. As you can see, it detects my face in real time. There is also an annotated matte output here that can be converted to a bitmap. I'm gonna use the display bitmap component to see everything in the viewport, in the Rhino viewport. Face detector has another output with face landmarks in it: eyes, ears, nose, and lips. Let's try another component from the vision task. This one is called face landmarker. It gives us a 3D face mesh in real time. Here is the annotated matte again. There is a face mesh component in the Utilities tab that gives us a mesh with the same structure. We can use this mesh as a source of mapping. Let's give it a try. First, I'm going to bake it, then draw a polyline on it, and then I'm going to use the mesh map component from the Congru to map this polyline on my face. And here is the result. There is also a deconstruct face mesh component in the Utilities tab that gives different face parts as polylines. Here we have two other outputs that can be used to detect facial expression like this. We can also use this component to detect more than one faces. Let's try it on the image that we have just used. As you can see, we need to change the non-faces input to 2. Here is the hand landmarker. You can check whether it detects right hand or left hand. You can change the num hands input to detect both hands at the same time. There is a polyline output that gives us the palm and fingers. We can add thickness using multi-pipe component, like this. There is also a category output that can be used to label hand landmarks. There is also a finger counter component that counts fingers like this. It can tell which finger is open and which one is closed. There is another component called hand gestures. It can detect 7 different hand gestures: open palm, closed fist, I love you, pointing up, victory, thumbs up, thumbs down. Here is the image segmenter, one of the components with more than one machine learning model. We have different options as you can see here. The first one is a selfie segmenter, which is more fast and accurate. Let's try the last one. The main output of this component is a list of grayscale masks. Different masks are labeled, so we can use any of them by using its index. Let's try body skin, for example, or face skin. You can also find an image contour component on the Utilities tab that creates a polyline based on the chosen mask. We went through most of the components in this video together. The rest works almost the same. We are gonna take a quick glance at the other components.